International Space Station is in orbit approximately 225 miles above the surface of the Earth, traveling at a speed of about 17,500 miles an hour. At that speed, it circles the Earth once every 92 minutes. When it's complete, it will be visible to 95% of the Earth's population. But even in its unfinished state, the ISS plays a critical role in preparing us for deep space travel.
Things we're doing on Space Station today will be needed when we go to the moon. They'll be needed when we go to Mars. If we have a part that breaks, we can fairly easily fly it to Space Station. To fly that same part to the moon is not nearly as easy. To Mars, it's almost impossible. So you can think of it kind of like a stepping stone. We're kind of getting further and further away from home. We need to learn to operate with those ties to home broken. And Space Station gives us a first chance to go do that and demonstrate that we can do that before we have to go do it on the moon and then before it becomes mandatory for Mars.
The lab module is called Destiny. And this is where we do the bulk of our work here.
Even as a work in progress, the station is an invaluable resource for studies that could never be done on Earth. On a recent flight, astronaut Mike Lopez Alegria demonstrated a few.
Here are a couple of experiments. One in particular is pretty interesting. This European delivered MELFI, which stands for minus 80 degree laboratory freezer. It's in fact closer to minus 100 degrees right now, and I thought I might show you where we like to keep our ice cream if we had any on board. It's about a minus 100 degrees centigrade. So that's quite cool. One of the things that we're very interested in, of course, is what happens to the human body as we're subjected to long periods of microgravity. And we can measure what we intake by basically notating everything that we eat or drink in a certain period. And then our blood samples correlate how our body is processing those. And, of course, the blood samples we can't analyze on board, so we freeze them for later analysis on the ground. This experiment is called Spheres. It's a satellite system. We have a couple of them, actually. But it uses CO2 gas to maneuver itself. And we can actually get these two satellites to fly in formation with each other and actually dock to each other. So that's a pretty fun experiment.
The ISS has already provided scientists with a wealth of tantalizing data. The Laboratory of Space has opened up lines of scientific inquiry that were unimaginable just a few short years ago, accelerating the development of treatments and cures for a wide range of acute and chronic diseases.
The results we're getting in tissue culture using controlled gravity systems is already putting key pieces of the puzzle of tissue engineering together, a day when we will be building organs to order from a person's own tissue.
The complex demands of building, working, and living on the space station have also spawned remarkable advances in technology, especially robotics. Small, floating, voice-directed personal assistants, virtually controlled robonauts, and the massive remote-controlled robotic arm are all examples of tools and technology created by human necessity and purpose.
I think probably Space Station is really a testing ground or a proving ground to test out engineering concepts, to essentially learn. So as like maybe early explorers got in sailing ships and sailed and they learned and then carried those experiences to the next generation, I think Space Station can do the same kind of thing for us. It can be a training ground, a proving ground for us to learn new concepts.
But while we can invent new machines to help us reach distant planets, we can't invent new bodies. So perhaps the most important research taking place on the space station concerns the ability of humans to physiologically and psychologically withstand the rigors of extended space travel.
The adaptation of humans and complex life forms to space is one of the first hurdles we have to overcome, and an important reason why we want to go to the moon, to understand how to get to places as far away as Mars.
The trip to Mars is about a 6-month trip, which is about the duration of my stay on the International Space Station. So the space station becomes our analog for a long-duration transit to Mars.
One area of great concern is the loss of bone mass that occurs with prolonged space travel. In the weightlessness of space, astronauts' bones don't need to support their body weight. It causes muscles to atrophy and leads to a condition called disuse osteoporosis. In fact, astronauts lose up to 1.5% of bone density for every month spent in space. To minimize that loss, They exercise on a specially outfitted treadmill and other equipment for up to 2 hours a day. But bone loss isn't the only concern.
Another one is radiation. The radiation environment is fairly high in space, and we need to look at how we can protect the human from the radiation environment and understand it a little bit better. That also may lead to some basic research in the cancer area as cells mutate or change. And then the third area is just being kind of removed from your family, removed from normal day-to-day things on the Earth.
Not being able to see Earth. Earth's going to be just this little speck out there in the distance, as opposed to, when we fly around it in low Earth orbit. And it's big, it's close, and we could get back home in hours if we needed to. Mars, you're gone for a long time. So there's some psychological issues that we're going to need to deal with also.
The terrain below, how would I say it? It is an experience that makes you really appreciate what we have down there, that it's fragile, that we need to protect it. And you feel very detached from it, and sort of you miss it. It's your home, it's where all your loved ones are, where all of your experiences have happened, and you really get a sense of being separated from it in a way.
The human beings we send into space are explorers, astronauts, and yet we use them also in some ways as patients. They are patients. And as patients, we watch how they do with non-invasive monitoring and things like that. It's important. They are at the edge of the envelope of that frontier in space. We need to know how well they do.
I like it so much.
One of the most immediate issues deep space travelers will face is nutrition. Indeed, the success of lengthy future missions could very well depend on the space station menu.
Well, living in space today is done on the International Space Station. Part of the experiment of living in space, the experiment we need to do to be able to go beyond living on the moon, onto Mars, involves such, in some cases, mundane things as nutrition.
Nutrition has always played a vital role in space exploration. Since the early days of Tang and freeze-dried chicken salad, food systems have evolved along with the space program. In preparation for future missions that will take us beyond Earth's orbit, researchers continue to use ISS to study the effects of long-term spaceflight on the human body.
We have nutritionists, nutritional experts, physiologists, all working together to see how do we make the living in space experience the most helpful, the most long-term sustainable. Because the trips to places like Mars eventually will require multi-space station scale rotations to undertake them. I mean, as far as we can imagine today, a trip to Mars would be equivalent to 2 full 6-month rotations on a space station, if not more.
With the help of the astronauts on ISS, scientists now know that extended periods of weightlessness can severely impact the human body. So watching what you eat is even more important in space than here on Earth.
This is orange pineapple drink, and of course, you got to be careful. I would be remiss if I didn't do the obligatory orange bubble trick. Fluids in space end up taking the form of spheres to reduce or due to surface tension, and you can sort of play with it as much as you want. You can blow on it to get it to do certain things, but the best thing to do with it is eat it.
We monitor not only the intake, of course, of calories and foodstuffs for energy, which is needed to undertake the activities, but we also watch indicators on the crew as they go and return. Bone loss, muscle decay. So nutrition is part of the equation of living and working in space.
Preparing for human missions into deep space will require a multitude of technological advances, not to mention just the right diet. And this is one of the many valuable lessons we're learning on the space station.
That kind of idea, using the space station as an element in the trip to Mars, could be invaluable. But again, we do not, at least from my understanding, have full depth of knowledge on what it will take nutritionally, in terms of diet, for the long Mars trips. We're just learning on space station what works best. And that's why space station is so important.